Hi children, welcome to Euclid Learning. This is the third part of grade 10 chapter 3. So if you haven't watched my previous videos, please go and watch the grade 10 playlist first because this is actually the third chapter and it's the third part of that particular chapter, right? So in this chapter, we were talking about number systems and we have discussed some of the conversions where we use the decimal numbers and we try to convert those numbers into binary, octal, and hexadecimal. So today we are going to learn more conversions, right? So if you see this graph, right, this picture, you can see we are doing so many conversions. Like already we did from decimal to other number systems we did, but today we are going to do like octal to decimal, hexadecimal to decimal, and binary to decimal, and between binary to octal. Like that, we are going to do more conversions in this chapter, right? So the first type we are going to talk today is about binary numbers, how to convert the binary numbers to decimal numbers, right? So hope you remember binary numbers will have only 1 and 0 digits, right? 1, 1, 0, 1, and with the base 2. So it's a must to put this base. If you don't put your number base in your answers, then it is wrong. Actually, you won't get much marks there. So make sure you are putting the decimal, other than the decimal numbers, always try to put the base into your numbers. Okay. So in this one, we write down this number and we are going to use the weighting factors. Actually, I have discussed this in the part 1 of chapter 3. So in now this is a binary number. We are going to convert it to a decimal number. So for that, we have to use binary weighting factors. That means 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. Like that, we have to use the weighting factors with the base 2, right? So what you have to do is like 1, you have to multiply with this weighting factor. Understood? And 0, you have to multiply with this weighting factor. 1 into this, 1 into this. So there is a small printing mistake here because it should be 1 into 2 to the power 0. So you hope you know any number to the 0th power will be 1. So that means 2 to the power 0 is 1. So here there's a printing mistake. So it should be 1. 1 into 1 is 1. Okay. So 0 into anything. Actually, you don't have to worry what is 2 into 2 to the power 1 because 0 into anything is 0. And then here 1 into 2 to the power 2. 2 to the power 2 means 2 into 2. That means 4. So 1 into 4 is 4. Here the weighting factor is 2 to the power 3. That means not 2 into 3, not 6. Don't do that mistake. This is 2 to the power 3. That means 2 into 2 into 2. That means 8. Okay. So 8 into 1 is 8. Now think there's another number here. So that should be multiplied with the weighting factor of 2 to the power 4. 2 to the power 5, 2 to the power 6, like that weighting factors will come. So here we have to stop with 1 into 2 to the power 3, that means 8. Then you write all these numbers and you have to add them. 8 plus 4 plus 1, that means 13 with the base 10. Understood? So this way also you can do. Anyway is okay. The representation is okay, but the mathematical thing you have to do is actually each of these digits you have to multiply with the relevant weighting factor and you have to add all the answers together. That is how you should do this, right? So we'll see how this activity can be done. So please pause the video and do this activity and then come back and see whether your answers are correct. Okay, so this is the first one, right? 101, right? So this is a binary number. You have to convert it to a decimal number. So again, you have to write this number 101 and then you have to write the weighting factors to be multiplied, right? 2 to the power 0, 2 to the power 1, 2 to the power 2. So 1 into 1, because any number with 0th power will be 1. So 1 into 1 is 1. 0 into anything, you don't have to worry, it's 0. And 1 into 2 to the power 2. That means 1 into 4 is 1. 4. Sorry, 1 into 4 is 4. So that means 4 plus 1, that is 5. So number 5 in decimal, you can write in binary as 101, right? So actually you can recheck your answers in the exam also. Quickly take this number and divide it by 2 and get the remainders, the what we learned in the earliest chapter, earliest video. You can go through that and just convert it back and see whether the answers are correct or wrong, right? Now this is the next one, right? So here we have a huge number. Don't worry, right? Write down that number like this: 1, 1, 1, 0, 1, 0, 1, 1, 0. You have to write that. And then you have to write the weighting factors into 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7, 2 to the power 8, right? And you start. Now 0 into anything, don't worry, it's 0. 1 into 2 to the power 1. 2 to the power 1 is 2, right? 2 into 1 is 2. This one, 2 to the power 2 is 4. 4 into 1 is 4. 0 into anything, you don't have to worry. Just put 0. And 2 to the power 4 is actually 16. That means not 2 into 4. That is 8. This is 2 into 2 into 2 into 2. That is 16. And multiplying with 1. So easy. 16. 0 into anything is 0. You don't have to calculate that 2 to the power 5 is 32 and don't do that. Just put 0. And 2 to the power 6 is 64 into 1 is 64. 2 to the power 7 is 128 into 1 is same thing. And 2 to the power 8 is 256. So you have to add all of them and then you can get the answer, right? Now make sure you do so much calculations and get this thing. Like you should know 2 to the power 8 is 256, right? In the O-level exam, don't try to do it and see 2 into 2 into 2 into like that, because that means you are not prepared enough, right? If you have done questions, actually 2 to the power 8, you should know by like it's a fact kind of, right? Okay, next one. It's again a huge number. Don't worry, just write it to 1 0 1 0 0 1 0 1 1 1. If you have a lot of zeros, you are lucky, because then 0 into 0 is very easy. You can just tell 0. So 2 to the power 0 is 1. 1 into 1 is 1. 2 to the power 1 is 2. 2 into 1 is 2, right? 2 to the power 2 is 4. This one 0, don't worry. This one 2 to the power 4 is 16. This is 0, this is 0, right? And 2 to the power 7 is 128. This one is 0, don't worry. Don't calculate 2 to the power 8 and then into 0, because 0 into anything is 0. Then 2 to the power 9 is 512. You add everything and you will get the answer, 663. Okay, hope you understood, right? So binary to decimal. So same thing, similar approach we can do octal numbers to decimal, right? Here there's an octal number and you have to convert it into decimal. So for that you are going to take weighting factors with 8 to the power, right? So here you just write the number 1, 2, 7, 5 and you write the weighting factors. 8 to the power 0, 8 to the power 1, 8 to the power 2, 8 to the power 3, right? So 8, any power into 0 is 1, right? That means 5 into 1 is 5. 8 into the power 1, right? It's just 8. So 8 into 7 is 56. 8 to the power 2. This is 8 into 8, that is 64, into 2, that means 128. This is 8 to the power 3. That means 8 into 8 into 8. That means 512 into 1. Same thing. And you add everything and then you can get the answer 701. Okay. Yeah. So please pause the video and do this activity. Then we'll check the answers. Okay. Octal to decimal. So this is the octal number we got, 230, right? So 230, just write it down and then write the weighting factors. 8 to the power 0, 8 to the power 1, 8 to the power 2. So anything into 0 is 0. So just write 0. So here it's 8 into 1 means 8. 8 into 3 is 24. 8 to the power 2, that is 64. 64 into 2 is 128. So then you add everything and then you can get the answer 152 with the base 10. Next number, 745, right? 745, just write it. And then you write the weighting factors, 8 to the power 0, 8 to the power 1, 8 to the power 2. So here, 1 into 5 is 5. Here it's 8 into 4 is 32. Here it's 8 to the power 2 is 64. 64 into 7 is 448. You add everything and then you can get the answer. Okay, this is 2064, right? 2065, right? Again, same thing. 8 to the power 0 means 1. 1 into 5 is 5. This one, 8 to the power 1 is 8. 8 into 6 is 48. 0 into anything, just 0. 8 to the power 3 into 2, that means 1024. And you add everything, you can get the answer. Okay, now we are going to convert hexadecimal numbers to decimal, right? Same thing, but here the only difference is the weighting factors will be with the 16 to the powers, right? So here 9, 2, 3, right? You write them down and 16 to the power 0 is 16 to the power 0, 16 to the power 1, 16 to the power 2, right? So this is 1, 1 into 9 is 9. This is 16. 16 into 2 is 32. This one is 16 to the power 2. That means not 16 into 2. That is 16 into 16. That means 256 into 3. So you get the answers separately and add them all, then you can get this number. So this is actually, if you get this done in mathematics also, it will be very helpful for you definitely. So they have given you another example, AB2, right? So you know here A is actually denoted with number 10, right? So we just write AB2 and then write the weighting factor 16 to the power 0, 16 to the power 1, 16 to the power 2. So A means actually 10, B means actually 11 because we have 0 to 9 digits and then we have the letters. So here, this is 6 to the 0 is 1, 1 into 2 is 2. Here 16 into B, B means 11, 16 into 11 is 176. This one 16 into 16 into 10, that means 256 is 16 to the power 16. So 16 to 16, then this is 200, 2000 and 2000. Okay, this one. AB2, right? So we'll write them down AB2 and then write the weighting factors 16 to the power 0, 16 to the power 1, 16 to the power 2, right? So here 16 to the power 0 is 1, 1 into 2 is 2. 16 to the power 1 is 16 into B means it's 11, right? So 11 into 16, 176. So here 16 to the power 2, that means 16 into 16 and into A. A is actually 10 because we know in the hexadecimals we have from 0 to 9 we have digits and then we have A, B, C, D like that letters. So here the full answer you can get by adding these three separate answers together. Okay, so pause the video and do this activity and then we'll check the answer. It's 1A, so that means 1 into 6 to the power 1 and A into 6 to the power 0, right? 6 to the power 0 is actually 1. So 1 into A is 10. So 10 into 1, so 10. So 16 into 1 is actually 16. So that means it will be, answer will be 26 with the base 10. Okay, next one is 7EF, right? Write them down, 7EF. So this is 16 to the power 0, 16 to the power 1, 16 to the power 2, right? 16 to the power 0 is 1, 1 into F. F is 15. So 1 into 15 is 15. And here it's 14, 14 into 16. Here it's 16 into 16, 256 into 7, then it's 1092. So you add them all, then you will get the answer as 2031. Okay, so here it is A49 with the base 16. So write them down, A49. So then write in the weighting factors, 16 to the power 0, 16 to the power 1, 16 to the power 2. So 16 to the power 0 is 1, 1 into 9 is 9. This one is 16 into 4, that is 64. Then here 16 into power 2 means that 256 into 10. So that will be A is 10, so that is how I got 2560. So then you add everything together, then you can get the answer 2633. Okay, so then we are going to talk about how to do the conversions from binary to octal, right? So now decimal to other number systems and from other number system to decimal, that is done, right? Then we are going to talk about binary numbers to octal. So before that, here they have given you some kind of a learning what we have learned. So in the octal number system, we use the digits from 0, 1, 2, 3, 4, 5, 6, 7 up to 7, right? So 7 actually we can write 1, 1, 1. That means this is 7 is the largest octal in the number system. That's the largest digit. So that one we can write in the binary form with 3 digits, right? So we can write all the numbers with um, 3 digits like that. So this is the table for that. So for example, 7, you know, it's 111, 6, 110. Like that, even it is 0, you write with 3 digits because then we can say that this particular octal number, this is how we are going to represent with the binary uh, scale in the binary numbers, how to express, right? So here always octal numbers, when you are representing them in binary, we have to use 3 digits. Then you can understand what's actually happening. So based on that, now we are going to learn how to convert this binary number to an octal number. So first of all, this binary number you have to divide into 3 bits, right? So you have to start with the right corner, right? Always start with the right corner, otherwise this will be getting wrong. So start with the right corner and divide each with 3 numbers into like a cluster of 3. And always it should have 3. So if you take this number 101, if you refer the earlier graph or the table here, 101 is 5. So like that you can put 5, 1 means 3, and here it's anyway 1. So this is 135 in octal. So this is how a binary number we can convert it to an octal. So if you have a binary number, start with the right hand side, divide it into clusters of 3. Right? Sometimes for the first cluster you won't get any, like you won't get all 3. For example, uh, we'll get only like in this example you have additionally put zeros to make it a cluster of 3. So don't worry. So in this one, we can add zeros to the front, but always start from the right hand side and divide into clusters of 3. Okay. So please pause the video and do this, and then we'll check the answer. Okay. So this is the first number in the activity. So it is 100110001. So you start this number with the right hand side and divide into clusters of 3. So this one is okay. This one is okay. Actually, for this one, I'm getting only 10. So for the missing part, I'm adding a 0 additional, right? So this is clusters of 3. Then I'm converting this each cluster into a octal number. So this is 1, this is 3, this is 2. How to do it? If you have a question now, for example, here it is 0, 1, 1. You have to convert this binary number into a decimal. Like for example, here it's 1 into the 2 to the power 0. That means 1 into 1 is 1 plus 1 into 2. That is 2. 2 plus 1 is 3. That is how this one is we are getting. Okay, so when you get these conversions, if you have so many conversions to do, like in this case, it's easy if you draw the table quickly, then you can refer it and put the numbers. Like for example, if you see 1 1 0 1 1, that is 3. You should know it by heart. Like if you do so many questions, you will understand this one as a fact. So then the answer is 231 in octal. Okay. Next one. So this number you are going to write, start from the right hand side, divide into clusters of 3, right? And here it's having only 2 digits, so put a 0 in front. Then each cluster you turn into decimal number kind of, right? So this is the digits we are talking about. So 1 is actually 6. 110 is 6. 010 is 2. 101 is 5, and here it's 010 is actually 10 is 2. So the answer is 2. So this is these are the octal digits. Always refer to that chart. Then you will. This is the chart I'm referring to. So if you get 0, it's 0, 3 zeros. 1 is 001. 2 is 1010. 3 is 011. 4 is 100. So these are the like this number how to represent in binary format, right? This octal digit. Okay. So then when you write the answer 2526 with the base 8, like 2526 with the base 8. Okay, so here we are going to convert binary numbers to hexadecimal numbers. So similarly, in the hexadecimal number system, the value f is the largest numeric value. So f is actually how to represent, you know, f is how much, like a is 10, like that. Uh, 10, 11, 12, 13, 14, 15. So actually f is 15. So for the 15, you can represent 1111 with 4 digits. So if you check the hexadecimal numbers and if you try to represent them with binary, this is how it will be, right? If it's 4 ones like that, actually what you have to do is you have to, now for example, it's 4, you divide it by 2 and put the remainders like that, do it and get this number. Otherwise, you will think how to get this particular chart, right? So this is not a magic. This is consider this as a normal decimal number and try to convert it to binary, right? For example, A, it's 10. So 10 divided by 2. Get the remainders 10 divided by 2 like that. Continually do it until you get 0. Okay. So then you get the remainders and then you can get this answer 1010, right? But in the hexadecimal, when you are converting it to directly binary, we can just use the chart and do. For example, in this one, in this question, what you have to do is you have to divide from the right corner. You have to start with the right corner, and now it's 4-bit clusters, right? For example, this is the number. So divide into 4-bit clusters, right? In this one, you have to put additional 3 zeros because to make the cluster. So then this number and this one you definitely know it's 1, and this one it is 6, right? Refer the chart, then you will understand. So this is actually 16 with the base 16. If you take another number, so write down the number and start from the right hand side and divide it the clusters of 4. So here only 10 you have to additionally put. So then we have 3 numbers. So these ones separately try to make it to a digit, right? So this is 1100. So if you go back and refer the chart, so C is 1100. So that is C. So that is how this is coming. And this is D and this is 5. This one you should know 101 means, that means to, if you do the weighting factors and see, this is 1 plus 4, that is 5. That is how it's coming. Okay. So that is 5DC with the base 16. Okay, so pause the video and try to check the answers later. So this is the binary number we have, right? So write them down and then divide it into the clusters of 4, right? Start from the right hand side. So here luckily we have 8, so 4 by 4. And this is A and this is D. So DA with the base 16, you can get the answer, right? How to check this is A? So if you think about 1, 0, 1, 0, this is 1, 2, 2 into 1 is 2. This is again 0. This is 8. 8 to the 1 is 8. So 8 plus 2 is actually 10. That is how this A is coming, right? Binary to decimal conversions and just see. But to do that, before that, you have to separate into the 4-digit clusters. Otherwise, the question is going to be wrong. Okay. Okay, next one. So this number, you write it down and start from the right hand side and divide into clusters of 4. So here put an additional 0. Right? So this one is D, this one is C, and this one is 7, right? So then you can write 7CD with the base 16. This one, okay? So write them down and then starting from the right hand side, divide into the clusters of 4. So here I have to put an additional 0 because it's having only 3 digits for the first cluster. And this one, so 1, 1, definitely you should know it's 3. That means 1 plus 2, 3. Right? So this is AE, this is 4. So 4E3 will be the answer with the base 16. Now, we are going to talk about converting octal numbers to binary numbers, right? So here, octal means always remember 3-digit numbers, right? We can consider like that because each of the digit in octal we can represent using 3 digits in binary, right? So this is the octal number we are going to convert into binary. So write this down 457. So this is octal number. Always to represent octal number in binary we use 3 digits clusters. So 7, you make it a binary number and write it down. For 5, write it down, and 4, write it down. Now sometimes you will have like for example, say think here you get only 0 and 1, you have to put additional 0 here. You have to always make these as 3-digit clusters. Okay, so how to make 7 like this? 7, this is a decimal number. You convert it to binary number, divide it continuously by 2 and take the remainders, then you will get this answer, right? So 4, 5, 7, you can write like this with 3-digit clusters first, then write the whole answer together. So this is the binary number for this 457 octal. Okay, pause the video and we'll see the answers. Okay, so here it's 1 0 with the base 8, right? So 1 0, write it down, and each digit you have to represent with 3 digits, right? That is why here we are going to convert octal to binary, right? So 0 you can write with 3 digits, 3 zeros. 1 you can write with empty zeros in front. So this way, then you write down the answers. Actually, the first 2 zeros you can ignore. So actually it's 1 0 0 0 with the base 2. Next one, 2 4 5, write it down, and 5 is 101, 4 is 100, 2 is 10, but as a practice, each octal digits we have to represent with 3-digit binaries, right? So then we put additional 0 here, but it's not a must. So because the actual answer is 101001001. This front 0 has no value actually. Next one is 706 with the base 8, right? So 706 represent each of these octal digits with 3-digit clusters. So 6 is 110, 0 because we need 3 digits, we put 000, and 7 111. So then you write the whole thing together, you will get the answer of the conversion of this number to a decimal. Okay, then we are going to convert octal numbers to hexadecimal, right? Now this is a bit tricky one. right? So here we have to follow small steps. Now this is the number 1057. So write it down. This is octal. So octal number, first we are going to convert into binary as an intermediary. So for that we need to represent each of these digits into 3-digit clusters. So 7 is 110, 5 is 101, 0 you represent with 3 digits, 1 you represent with 3 digits. Then you write this whole answer together, right? So that is the binary number of this octal. But we need hexadecimal. So you know binary to hexadecimal we know. You have to start from the left end, divide this by 4-digit clusters. So the front ones we have to put additional zeros, right? So you divide into the clusters of 4 digits, and then this one, you know, it's 15. That means F. This one is 2. This one is 2. So 2, 2, F is the answer. Understood? So this is a bit tricky because first the octal number, you have to convert it into a binary, then group into the 4-digit clusters, and then again translate that to uh, the next hexadecimal conversion. Okay, so we'll see the answers. Okay, so we have 320 with the octal base. You write this down. This is octal number. So represent this, each of them with 3-digit clusters. So 0, 0, 3 zeros. This is 2. This is 3. You represent with 3-digit clusters. So this is the number with binary. Right? So this binary number, now we are going to convert it back to hexadecimal. So you start from the right hand side, divide into the 4-digit clusters, right? So this one actually we have to put so many zeros. So anyway, it's no point 0. This is D, this is 0. So this one we can ignore. Actually, it's D0 with the base 16. 475 with the base 8, right? So this is the number, this is octal number. So write each digit with 3 digits of clusters like this. And then this is the binary number of this particular octal number. Then you start with the right hand side. Uh, each group should have 4 digits. Now for the first one, we are adding so many zeros to get the answer. So this one is D, this one is 3, this one is anyway 1. So 1, 3, D will be the answer for this with the base 60. Okay, next one. 1673 with the octal number, right? So write it down, and this is the octal number. Write each number with clusters of 3, right? So 3 is 1, 1 actually. You put a 0. 7 is 111. 6 is 110. 1 is actually 1, but you can put additional 2 zeros to make it 3-digit cluster. So this is the binary number of this particular octal number. So you start with the right hand side, right corner, and you divide it into digits of 4, that clusters of 4. So here you are adding zeros extra. So this one is B. Please refer the table I showed you. This is also B. This is actually 1, 1. You should know it's 3, right? So 3BB with base 16 will be the answer. Okay, so we learn octal to hexadecimal. Now this is hexadecimal to binary. This is not a very new thing, right? Now you can understand. So hexadecimal is 7, 4, 16. So I explained hexadecimals. We also always have to have binary representations with 4-digit numbers. So 4, you represent, it's actually 4 means 100, but you represent it with 4-digit cluster. So that is 0, 1, 0, 0. 7 is actually 111, but we put additional 0 because I want to make it clusters of 4. So this is how hexadecimal number you convert it to a just a binary number. It's not very hard. Now this one, same thing. This is 16 hexadecimal. Hexadecimal means you have to always make sure you follow with 4-digit clusters. So EA2, that E is actually 14. So 14 you make to the binary. and A is 10, that means 1010, and 2 is actually 10, but you put additional 2 zeros to make it 4-digit clusters. So then you write the whole answer with these 2 zeros, actually you can ignore. So this is the binary representation of this particular hexadecimal number. So here also we have some activities. We'll see the answers. First you do that. Hexadecimal to binary. 7, 8, 16. So we have a hexadecimal number. So write that down, 7 and 8. So this is a hexadecimal. That means we need 4-digit representation in the binary. So 8 means 1000. 7 means actually 111, but we put additional 0 to make it a cluster of 4. So then you can write this whole answer. Actually, the first 0 you can just ignore. Without even this 0, the answer is correct with the base 2. Next one, B2C16, right? So write them down, B2Z, right? C is how much? Now A is 10, 10, 11, 12. So C is 12. So 12 is 8 plus 4. That means 1100, right? 2 is anyway 10. We put additional 2 zeros because this is a hexadecimal number and we want to make clusters of 4. So B is actually 11. So 11 you represent like 1011. So then you write the whole answer. This will be the representation of this particular base 16 number. Next one, 4, D, E, F, right? Write them down. So F is actually, you should know it's 15. That means all ones. This is 14. This is 30. So convert those numbers to binary. 4 anyway, you should know by now. It's 100. So 100, we put additional 0 to make this with clusters of 4. Then you can write down the whole answer as the binary conversion. Okay, now we are going to convert hexadecimal to octal, right? So this is also a bit tricky, right? We'll see. Now this is the hexadecimal number. You first have to convert it into binary. You have to convert into intermediate because hexa to octal we cannot directly do. We need to go through the binary formation, right? So 2, 3, 4, 2, 3, A. So you convert each of them with 4-digit clusters, right? A is 10, 1010, 3 is 11. You put additional 2 zeros. 2 is 10. You put additional 2 zeros. So you make clusters of 4. Now this hexadecimal number you have converted into binary, right? This is the binary number. Again, the binary number I have to convert it to octal. So binary to octal, how to do is you have to take the binary number, start from the right hand side and divide into 3-digit clusters. So you have divided into like this, and then this is 2, this is 7, this is 0, this is 1. Actually here additional 2 zeros needed to be put to make it a cluster of 3. Then 1072 will be the answer. Remember, this is the hexadecimal number. This is the binary conversion of it. And then from the binary again, we got the octal conversion. So please pause the video and do these activities, all the activities, and then we'll see. Right, whole thing. Okay, so 320 with the base 16, right? So base 16 means you have to convert with 4-digit clusters. So 0 is 4 digits with 4 zeros. 2 is 10, but you put additional 2 zeros. 3 is 11, you put additional 2 zeros. So this is the representation in binary. Then you have to start from the right hand side, divide into the clusters of 3s, right? So when you divide it into the clusters of 3, here you have to get the same thing with 2 digits. Then 0, this is 4, this is 4, this is 1. So 1440 with the octal base. Next one. A7B16, the base 16. So A7B, write it down. So A is 10, B is 11. So accordingly, you have to make each of digits binary format with 4 digits because this is a hexadecimal number. So B is, I told you it's uh, 12. B is actually 11. So 11 you have done with 8, 2, 1. So that is 11. This is 7. And this A is 10, 1, 0, 1, 0. So this is the binary formation of this particular hexadecimal number. Then you start from the right hand side, divide it into the clusters of 3, right? Then each number, this is 3, this is 7, this is 1, 1, 0, 1 means 5. So 5173, this is the octal number of this hexadecimal number. Okay, so 10ED16. So this write it down and you have to convert each of these digit into 4 digits of like binaries, right? So D is actually A, B, C, D. That means 10, 11, 12, 13. So 13, you have to convert and get this answer. This is 14 and this is 0. No worries, you can put 4 zeros. 1 is 1 actually, you put 4 zeros. So this is the binary number of this particular hexadecimal, but we want to get the octal. So start from the right hand side, divide into the clusters of 3. And then you write down this answer and this will be the octal representation of this particular hexadecimal number. Okay, so in this one, what they're asking is, like consider the number 2, 3, y. So y is the base of number system, right? So what are the number system this can be belong? Can it belong to binary? No. Why? Because it has only 1 and 0. So here it's have 2 and 3s. So binary cannot be. Then we have hexadecimal. Yes, can have. And octal, yes, we can have because we in the octal we have 0, 1, 2, 3, 4, 5, 6, 7. Right? And then in the decimal number system also we can have. So all these 3 number systems can have this number. Then they're asking you to convert the decimal number 83 to binary number. So this is the first answer. This is 83. You are going to represent it binary. So you have the 83. You divide continuously by 2 until you get the 0 here. And you take all the remainders from bottom to top. Bottom to top. 1, 0, 1, 0, 0, 1, 1. And they are asking you to convert this binary number to a octal. Binary to octal. So this is a binary number. So to convert it to octal, you have to start from the right hand side, divide it into the clusters of 3s, right? And here you may have to put additional 0. Then each of these 3 clusters, you can separately convert it into decimal numbers and get this value 267 with the octal base. And the last one they are telling, convert the hexadecimal number 2, 3D to a binary number. 2, 3D, so to a binary number. So write this down. So this is hexadecimal. So you have to go with the clusters of 4 digits. So D is 1101, 3 is 11, you have put additional 2 zeros. 2 is actually 10, you put additional 2 zeros and you can write this whole number, even these 2 zeros you can ignore. So this is the binary number of this particular base 6. Okay, in this one, I will tell you how to do it and I will show you the answers. So what has they done was this is a colors, right? This is a color graph, right? Color chart. So here we have several colors and we have the RGB colors, right? So here how to get the hexadecimal value is you have to put this hash sign. It's a must. And each of this number now if 135, you convert this decimal number into a hexadecimal. Remember how to do it? Yeah. So this particular decimal number, you have to convert into hexadecimal. So decimals, how to convert is you divide continuously by 16 and then you get the remainders and then you can get the answer. So for 135, your answer will be 87. For 31, it's 1F. For 120, it is 78. that means 120, this is a decimal number, you convert it to a hexadecimal. Got it? Understood. So from that, you got this answer. For example, 31, you divide by 16, right? How much you will remain? When you divide by 16, you will have 1 and 15. Okay. So then you again divide 1 by 16, then you get 0. So 0, then you will get the answer. There's a 1 remaining. So 1 and you get 1 and you get 15. So 15 is F. That is how 1F has come. Understood? So I will put the answers. Now, for example, this one, you divide by 16 continuously and get the answer. So each 2 digits will represent these numbers. In these cases, it's very easy. It's 0. So you can just put 2 zeros in front. Okay. So these are the answers. Now I told you this one, 2 zeros, 255 is actually FF. And then again 2 zeros. Please put the hash mark, then otherwise it's going to be wrong. So these are the answers. Try it. If you have any questions, you can put a comment and we can discuss it in the chat. So hope you understood. Yes, I know there were so many conversions and sometimes it's a bit tricky to identify and memorize what is the correct method. So please go with a short note for your own, right? That means from decimals to or any decimal to binary, right? Any decimal to any binary or to octal, right? From decimal to other number systems, what you should basically do, you divide by the particular number and you get the remainders, and that's the way. And from any numbers to the decimal number system, it's actually you use the weighting factors, right? Then comes the other conversions, which are a bit tricky, like octal to hexadecimal, hexadecimal to octal, right? Those things we cannot directly convert, right? We should go with the usage of binary numbers. Actually, they have done octal to binary octals as well, because it's with that approach we can move on to the next level, where octal to hexadecimal, hexadecimal to octal also we can convert. Right? There's not very hard, but yes, I admit that for the first time, yes, it's so many conversions and you will feel a bit hard to remember, but there's a pattern. If you can make a short note and get the pattern right, this chapter is very easy for you. Okay. So this is not the end, not the end of chapter 3. We'll have another part for the chapter 3. So hope you enjoyed my video. Please do subscribe if you haven't subscribed, and please do comments if you have any questions of any conversions, how to do and all. Please let me know. And in the online, like in web, you can find so many online conversions supporting softwares, kind of like even the online converters are there. So if you find some convert like that, then you can easily check your answers, like decimal to octal converters are there online. So you can check your answers by yourself, but don't copy the answers and put. Do the math or do the question yourself and then check the answer with those tools. Okay. Okay. Thank you very much.